there's a lot of talk going about earthquake retrofitting. Yes, everybody's houses are concerned, they're damaged. So I happened to be at Patan, and this is how they were trying to retrofit with these wires. This was their connection, and I just kind of got crazy, you know, this is steel. Wow, modern things going on, right? Big nice steel, they put it here. Did they really retrofit? So I just took one element. So there's a formula that we use to calculate how much force is involved in those walls and to see if they are anchored enough. I came with a very large number, and that's required 8 anchors on a foot. Cannot get it. And with those ties, these ties do you no good. So this all has to be, every step of this has to be engineered and calculated in retrofit. It is repair. Essentially, we got the datuanga, which is like 24 inches wide, generally in most houses. Then we have the exterior walls, right? Then we got the 2 exterior walls, and there might be or might not be interior walls in here. And this is for just a 1-story building. I took about 8 foot high. I calculated some stuff, and I said, how much force is going into this datuanga? So half of this force goes here, 1/4 goes there, 1/4 goes there. Distribution, just ordinate. That number turns out to be 205 kips, but that gives me a stress of 18 pounds per square inch. Whereas the allowable by design criteria, engineering design criteria, for a well-built concrete masonry brick building is 3. I am at almost 6 times. No wonder these walls are not doing what they're supposed to be doing. Now what if I took that wall out? I'm just trying to show you where engineering can help you. I replaced it with some kind of an engineered system here and an engineered system here. I replaced it with a beam, a column. Now the new earthquake force is 180 because I took this whole mass out. And I calculated that these are needed to be about 12 feet. I'm getting a better building, which is now taking in less earthquake load. So we could take these older buildings and make use of them without really destroying them, or trying to strengthen the existing walls with some crazy ideas that I kind of showed you that time. So I could do that on all the 4 sides too. And then with that open space, I could do a certain thing. If I started to lay some partitions walls inside, now I have got almost a 24-foot wide space, 50-foot wide. I can play around with it. I can get a couple of rooms that you can live comfortably in a modern way rather than the old way. I can at least get a bathroom in there. I can get a bedroom in there. I can get a kitchen in there. Okay. Thinking, this is all conceptual now. But it all has to be engineered, and the architects and the engineers have to work on this together. So on the old ways, the total load was 479,750 pounds. The weight of an Airbus is 81,906 pounds. So it is almost 5 times heavier. So you can imagine, the heavier a building is, the more load it draws during an earthquake. And that's where the damage starts to occur. Therefore, if you can make these buildings lighter and do other things that we can do, then we help. So for example, this is from my house. This is a datuanga 27 inches wide. But if I were to take that and replace it with that concrete, remember I told you, 8 inches maybe, and then put the exterior just like this, I get my look on the inside. I could put plaster and get my comfort like that. So I have a usable room, right? The weight with that was like 25,570, so I almost reduced by half. There are a few things, and there are some crazy ideas. I've written them down here. Replace mud floors, convert choke spaces, re-engineer traditional building for all loading conditions, including earthquake loads. You cannot ignore it. Remove datuangas, provide desired safe room layout, circulation, relocate kitchen and living spaces to ground floor. The big complaint I hear is this. All of us are outside, and all our elder fathers all say, all these kids went outside and they don't give a damn about us. Yes? How many of us have heard that? But the argument I'm making, if my father would only agree to go from the 3rd floor of the house, traditional house, to come down to the first floor, which I can make modern, his social life would improve, his family life would improve, he could go out and take his walks. If he's got a disability or he's elder, right? Because he don't have to navigate the stairs. And he cannot blame the bohari for not bringing the food down late and cold, because the kitchen is right there, right? So, and then the other thing is, this thing is coming up from Kiran's. Please underground all utilities. This is the right time to do it, because that's going to clean up your entire system, and it may even provide an avenue for rescue. And you can, if you want, you can discuss a little bit here. What are other possibilities you see? Just common sense possibilities. If you do, you can make Kathmandu and Nepal safer. This is my end, and I still have conviction there's hope. But let's live, I kind of live with this motto. But we have to kind of understand the simplicity of the issue. Let's not make it too complicated. Let's not make it too research-oriented and project-oriented. Let's look at it so that public safety can be ensured using modern techniques that are just readily available. No research is necessary.